Okay, so today our goal is to teach you how to, on day 3 here, solve log equations where x is in the base. You're going to basically take logs, and if you really understand them, you'll be able to write equations with them. And then you're going to take the equations and solve them. So let's look at this one. This one has the cube root of 49. This is the most important thing here, that you know that if I got it to be log base 7 of 7 to the, let's say, 2/3 or whatever it's going to turn out to be, then the answer is going to be 2/3. If these two numbers are the same, then that number is the answer. Why? Because if I say equals x, then I can rewrite this puppy and say 7 to the x equals 7 to the, well, whatever. Let's say that this had been a 2/3. 7 to the x equals 7 to the 2/3. That's a rewrite. And once you've got the bases the same, that has to equal that. So x must be 2/3. And actually, the answer is 2/3. Can you see why 7 to the 2/3 is the cube root of 49? Take 7 to the 2/3 for a second and say 7 to the 2/3. That's the cube root of 7. Well, I don't even know what that means, but then there's 7 squared. I could do that, right? So maybe in this case, I should actually do this first. Do you have to do the square rooting first? No. The cube rooting in this case. So if you take the 7 and you square it, you get the 49. And then you do the cube root part, and then you have the cube root of 49. You see how that worked? Do you get that this right here is equal to that right there? 7 and you square it gives you 49, and you cube root it gives you that cube root right there. All right, so then when you rewrite it like this, it becomes obvious because these two are the same. The answer is 2/3. 2/3. Any questions on that one? Move on to the next one. First step, subtract 7. Next step, divide 2. See if you can do it from there. Okay, let's get there. All right, so you should have subtracted 7. And then you got 4. And then you got to get rid of this 2. And that would be divided by 2. So the 4th root of x plus 1 is equal to 4 divided by 2 is 2. There we go. And then how do I fix this 4th root? You put it to the 4th. That's what undoes the 4th root, is putting it to the 4th power. And then I get x plus 1 equals 2 to the 4th is not, yeah, it is 16. I was thinking it was 32, but it's 16. Okay. No, not yet. Put it to the 4th power. I put it to the 4th power. That doesn't make plus or minus. But now, when I square both sides, is that going to cause something? Oh. Wait a minute. Wait, I did this wrong. Hold on. I'm sorry. What is wrong with what I wrote right there? Something is wrong. There's no square root sign. Sorry. Okay. The square root sometimes does cause the plus minus thing to happen, but that's if I square rooted both sides, and I never did that. Okay, so what I did wrong, though, is that takes this out of the picture, so it's gone. That's just x plus 1. So then I just subtract 1 from both sides. X equals 15. Any questions on that? All right, I'm going to move on. This one. This should be something that you can rewrite if I say equals x. Everybody rewrite that puppy. Don't try to make 36 into 4 to the something, because it won't. That would be a good idea if I could write 36 as 4 to the something. But since I can't, 4 to the what? It doesn't make any. I can't make it 4 to the something. I actually can, but it's really complicated. So instead, you should do it this way. Since there was no x in the problem, I can say equals x. And then rewriting is the most important skill of logs. To be able to take a log and write it as an exponent problem, as opposed to taking an exponent problem and making it into a log. Back and forth, that's the thing. So please rewrite this and then turn it my way and let me tell you if you're rewriting it the right way. Yep. Don't know what to do? Oh, yep. Yours is backwards from everybody else, but it's still right. Yep. Nope, you're solving it, I think, but you can't. So, good try, but turn yours sideways so he can see it. This is what I'm looking for. Yup. Okay. So, you should have been saying 4 to the x equals 36. Now, why is that any better? Because now we can change both bases. You get how I couldn't rewrite this as 4 to the something very easily? So instead, I'm going to change them both to have a base. Can they both have a base of 2? I was thinking 2 could be made into 36, but maybe it can't. 2 to the 5th is 32. All right. Well, there's a really important with calc on the side here. So given that, okay, now it's important for you to see what I would have gone through. I mean, it's what I did go through. You saw me go through it. I'm like, wait a minute. I rewrite it, and it still doesn't make sense. I thought we could rewrite it and say 2 to the second to the x, and then 2 to the something would make 36, but it doesn't. So that's why that method doesn't work. So then I go back to the calculator. And how do you put that in the calculator? It'll be really simple. Log 36, and then what? Divided by log 4. You are correct, Mr. S. Log 36 over log 4. Now, everybody type that in because you might think, well, that's super simple. But maybe you're typing it wrong. I want to tell you what everybody else is getting. Because there is a way to screw this up. If you put the parenthesis in the wrong spot or forget the parenthesis, you're going to get the wrong answer. Mr. P, what'd you get? 2.52. I got one answer at 2.58. Can anybody verify that? Several people. Okay. I want you to make sure you get 2.58 because otherwise you're doing it wrong and you need to know that for the test. All right. Now think for a second. What was the base in the original problem? 4. In the second problem, the base is not 4. What's the base in the second problem? There is no bases, so that means what is the base? They're both base 10. If you don't say a base, that means they're base 10s. So you just did a base change, it's called. This was base 4. When you rewrite it this way, it's base 10. Why is it necessary to rewrite it in base 10? Because your calculator, unless it has the newest version of the software, can't do any other base except base 10. So you have to change the base. Because when you type in log on your calculator, it just automatically goes with log base 10. All right, so log base 10 of 36. So this makes it possible to do in the calculator. All right, now let's talk about the 3 different kinds of log equations. There's 3 kinds you can solve. X is somewhere in the base, like right there. X is the exponent. The exponent's at the end. Remember why it's the exponent? Because if you rewrite it, 2 to the power of x, see, it becomes an exponent, equals 8. Or the third option is x could be somewhere in the argument. And we're going to basically learn all 3 ways of solving these, and they'll get complicated. But you could either have the x in one of those 3 places. It can either be here in the base, or here as the exponent, or here in the argument. And today, what we're doing is this one, where x is somewhere in the base. All right, moving on. So, as I said before, we're going to figure out how to do it when it's in the base. And this guy right here is a typical example problem. You just rewrite it, x to the 3rd equals 8, like that. And how do you get the 3 off of there? You put it to the 1/3 power. And then 8 to the 1/3 power is the same as the cube root of 8, which is 2. Now, why didn't I do plus and minus there? I did a root on both sides. Why didn't I do plus and minus? It's an odd root. Very good. All right. Now, I want to do another one that's similar to that. Log base x of, let me think here. I want to make this work out. Yeah. Log base x of 16 equals 2. Everybody rewrite that one and solve it. Just so you know, I bet only 4 people are going to get this right. Try to be one of them. Okay. 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 All right. Okay. I was wrong. Nobody got it right. What? Okay, so what? X squared equals 16, and you're all like, oh, I'm doing square root on both sides. X equals square root of 16 is 4, and then you knew it was absolute value, so you knew it was x equals plus and minus 4. Wait a minute, why could I be possibly wrong? Look at where the x is right there. Can you put a 4 and a negative 4 in there? Vicious. I know I am I got a monster streak in me. Because it comes out that you did all the work of being extra smart to know that it was plus and minus, but then you're actually wrong because of that. Because negative 4 can't go there because you can't have negatives there. So you have to actually say that x equals 4 is a right answer and x equals negative 4 is an extraneous. And I thought maybe somebody would take the time to check it back in the original, but all right. Yes, that is a monstrous problem. All right, moving on. This one. Everybody, rewrite. If you can do a rewrite, then this one becomes just like one of the ones on your exponentials test that we just had a while ago. Once you do the rewrite, it should be fairly easy. So to start with, it's x to the 3/2 equals 27. So then you put it to the power of, everybody says times it by. No, you don't. You're putting it to the power of 2/3. 2/3. Ooh, I did a root on both sides. Should it be positive or negative? No, I did an odd root on both sides, so it's not. Okay, and even if it was plus and minus, the negative would be extraneous. Anyway, back to this. This is canceling, and the x is equal to the 3rd root of 27. I can do that in my head. It's 3. And then I square it, and it makes 3 squared is 4. Right? Okay, how about 3 squared is 9? Raise your hand if you had that one. The same as me. Okay, good. All right. Now, what if I worked for an evil tyrant who was going to kill me if I had it wrong? I would probably check it. I'd stick a 9 right there and see if it actually worked. And then I would go, okay, 9 to the 3/2 should equal 27. Do you see what I'm doing here? I'm just rewriting again with the 9 in there. And then 9 to the 3/2, square root of 9 is 3. 3 to the 3rd is 27. That's all. It seems like it's working, right? So yes, it does work, and it's okay. The only other thing I might make sure is I didn't stick a negative in here or here, did I? Because that would be undefined. All right. This one, give it a shot. It adds an extra layer of complexity. Use parentheses in a smart spot. Pause while you work on that. Back from the break, and it says x minus 4. That's where the smart parentheses would be. Anybody remember that? Anybody know that? Okay. Why does it matter? Because if I don't have those parentheses, the 3/2 is only going to happen to the 4, and that's not good. All right, so then this has to be fixed. I put it to the 2/3, and then these guys cancel. X minus 4 is still left, and then this is cube root of 8 is 2, 2 squared is 4, and then I add 4 to both sides, and I have x equals 0. All right. What do you mean, no? Yes, that is an extraneous answer. Know why? Okay, fine. And plus 4. Okay, wait a minute. If I had gotten 0, do you get how I could have put it back in there and gone, oh, wait a minute. I have effectively a negative 4 in the base, and that's wrong. But I only got that because I screwed up. Plus 4 comes out to 8. It's a snowman. And 8 does work. If I put an 8 in here, 8 minus 4 makes me positive 4 down there. I thought it was another extraneous one, but it's not. If I really, really wanted to check it, though, I'd go 8 minus 4 is 4. 4 to the 3/2 should equal 8. And I go square root of 4 is 2. 2 cubed is 8. Yep, it works. All right, moving on. This one's just a little bit bigger numbers, but it's the same idea. The x is still in the base. Yeah, ooh, look at that, calc. Now, right off the bat, there's nothing you'd want to do with the calc, because you can't type a 3x plus 1 into the calculator right there, unless the method that I have told you over and over again is so underused on ACT test. Graph what? How do you solve this thing again? You could graph what? Graph both sides and see where they cross. Yeah, you did say it, but you said it in the way that I'd never say it. So graph both sides of the equation and see where they cross. That is a good way to do it. There is a slower way to do it, and that goes like this. But you know, the cool part is the slower way does not involve logs. You do a rewrite. You go 3x plus 1 to the 5th equals 239. So you'd pick. I don't care. You either graph the first one, graph both sides, see where they cross, or you take this one, graph both sides, see where they cross. Now, can you do this without graphing at all? Absolutely. What's the next step in solving this equation? Put it to the power of what? 1/5. But I like to graph both sides to see where it crosses thing. The only bad thing is a lot of times kids don't know how to make their window big enough so you actually see where they cross. Okay, but as long as you don't forget that, it's a great way to do it. So then I go 3x plus 1, and now I need some help. What is 239 to the 1/5? Or you could say 2.99? Anybody verify that? Yeah. All right, thank you. Then I'm going to go subtract 1. Effectively, that's about 3. So 3 minus 1 is about 2. So I suppose it's 1.99. 3x equals 1.99. And then I divide by 3, and that's about 2/3, which is about 0.6 repeating. So I'm going to say a 0.67. I bet that's about right. Okay, could you have graphed both sides to see where they cross? Yes. And it would have been, surprisingly enough, at 0.67. So it all depends on your abilities with the math, or with the graphing calculator, where you'd want to use it. The simplest thing of all is if you could type that into the calculator, but it's kind of a pain because you got to type in log 239 divide by log 3x plus 1. And then the other side of the equation is really simple, y equals 5. Another option is take this green one, graph it. All right. This one, notice it says no calc, and these are practice problems I want you to try. So there's 3 of them, this page and the next page. Answer those 3. You're going to take this like a little mini in-class quiz, and if most of you get at least 2 out of 3, I'm going to feel like we're probably okay to be done. So, give this little practice quiz a try. Notice it says no calcs. Just set it aside for now. Is that one of those new special kind of... Can I see it for a second? Well, it's pretty much a normal one, I guess. Okay, pretty much everybody says they're done. So here we go. X to the third equals 64. Now all I got to do is think, what cubed gives me 64? And the answer is 4. 4 cubed is 64. All right, on to the next one. I would rewrite this and say x to the 1/2 equals 5 halves. X to the 1/2 equals 5 halves. That means I should really square both sides. Squaring both sides does not cause the plus minus thing. X equals 25 over 4. Raise your hand if you had that one right. Good. There we go, 25/4. Moving on. This one. Log base 4x plus 4 of 32. Well, anyway, I'd rewrite it like this. 4x plus 4 to the 5/4 equals 32. Says no calc. That means I better be able to do power of 4/5 in my head on this one. 4/5. Oh yeah, the 5th root of 32. That's not that bad. The 5th root of 32 here gives me 2, and 2 to the 4th is 16. So 4x plus 4 equals 16. Subtract 4, 4x equals 12. Divide by 4x equals 3. Raise your hand if you got the same thing as I did. Okay, awesome. Let's see if we're right. Yay, x equals 3. Okay. All right, cool. How many had 3 out of the 4, or 2 out of the 3 right, at least? At least. Okay, good. This one, I don't think we need more practice, so we're good. Now, what kind of solving do we focus on today? Where was the x? The x was in the base. Good. And what kind of solving will we learn next? Well, we're going to do the kind tomorrow where x is in the exponent spot. And let me ask you, where's the exponent spot? C is the exponent spot. A is the base spot. And what is B called? The argument. And what if you won the argument? That's right. So if you put a 1 here, this is equal to 0. All right, good. All right, that's enough for today. Your assignment's worksheet logarithms A3. Hope this is feeling easy to you. And if it is, that's cool because logs is something that comes up again in pre-calc and then comes up again in calculus. So they're kind of fun once you understand what they do.